Welcome. This is the first video for Chapter 6. In this chapter, we're going to talk about functions, and we're going to find out a lot of bit about the beginnings from from spaghetti code, kind of what we've been doing so far, towards splitting code out, which is, again, even closer to any type of object orientation development you might want to do. This is kind of that first step to that. It's definitely not object oriented development, but it's definitely a first step. So let's dive in and talk a little bit about it. So, why do we even want to do functions? It really comes down to modular programming. In the old days, and being my age, I hate saying that. In the old days, back in the G basic days, we basically had one function, and we developed all our code in this one function. And if we needed to move around in the code, we used things like goto, even in assembler, we've got jump and things like that. And so what happens is you get this very complex set of code that's almost impossible to debug. It's almost impossible to give to other people to maintain, because it's just this long set of instructions, one after another. So what happened was we got a little bit better with programming, and we started creating this modular programming concept. And modular programming says we're going to take these code pieces and we're going to break them up into smaller, more manageable functions of code. And one of the reasons we want to do that is we also want to get good at not typing in code more than once. And I'm going to show you some examples of that here in a moment. But a function is a collection of statements that perform a task. So some of the motivation for modular programming involves maintainability of programs, simplifying the process of writing programs. It keeps your code shorter, and it's code reuse. We want to make sure that we're coding smart, not hard. So here's what we kind of talked about just a moment ago is so far what we've been doing is we've had all these statements in one main function. What we want to do now is we want to start breaking some of this code up into multiple functions. Well, why would we want to do that? Well, what if function 2 is something that we're going to do over and over and over again? Do we want these 3 lines repeated over and over and over again? Or can we break it out into a function that one line just calls that function, which does those 3 lines all together? Again, I'm going to show you here in a moment some example of that. So how do we define and call functions? Well, a function call is a statement that causes a function to execute. And we're going to do that. It kind of goes hand in hand. And this is the line of code that actually says do the function. Where the function definition is a statement that makes up the function. It's going to be kind of like our int main, but it's going to be a function. By the way, int main is a function. So we're doing the same thing, but we're going to define additional functions. So when we're defining a function, it has a return type. So far, all of our code has been returning an int, a 0 to be exact. And that's an int. So that's why it's int space main. We're returning an int. So it's the data type of the value that the function returns to the part of the program that called it. Our int main is being called by our operating system. So we're returning that 0 to the operating system. We have to have a name for the function, and there are some rules regarding the naming of functions, as well as a lot of organizations have some kind of coding standard on what you can and can't do with function names. For us here, I'm not going to be super strict about it. Obviously, you're going to have to follow the names that the compiler mandates. Beyond that, I just want your function names to be something of meaning, right? Don't have a function named Billy's function. That tells me nothing. I want to know what that function is supposed to do. That's the best way to name your functions. Like I said, a lot of organizations have strict policies, like if it's doing something, maybe the word do has to begin. I know for my organization, if you're asking for, like, say, a status, whether something is open or closed, then the first 2 letters of your function should be is. So it should be like is closed, is opened. And that's the other thing too, is we don't like past tense. So instead of is opened with an ed, it just is open. So again, depending on your organization, how you want to be a developer and your style will also really dictate your names. But for the class, just make them somewhat meaningful. Each function is going to have a parameter list. This is the power of functions. This is one of the things that we like about functions is that we can pass it variables so that way the results of that function can be different every single time we use it. But it still follows a certain pattern. And we'll see that here in a moment. And then the body, which is enclosed in brackets, and it's the actual tasks that are going to be performed within the function. So far we've been using int main as our function, and we can kind of look at this one, and we have the return type of an int. Normally I have my pen, but today we're doing it with mouse. So here is your return type, your function name. This is the name, and by the way, we are using main because that's what the operating system is looking for. And then we have that parameter list. Again, this one so far has been an empty list. But we always have to have these parentheses, even if it's an empty list. If we had some definitions, they would go within this parentheses. And then we have our body here. Now, the line that reads int main is the function header. So this is the function header, and we will get to that here in a moment, what that really means. So the return type. When a function needs to return a type, we want to indicate what the type is going to be. So in this case, we're returning int. If we have a function that doesn't return a type, which does happen quite a bit, instead we're going to say void. That's the type. Void means nothing's coming back. And as you can see in this function, we output something. We never return a type. So now when we're calling a function, to call a function, use the function name followed by the parentheses and the semicolon. If when called, that program executes the body of the called function. After the function terminates, execution resumes in the calling function at that point of call. So wherever our code calls out to the function, when it's done, it comes right back to that spot and starts continuing on. One thing, again, I want to iterate is if you had parameters, they would go in this parentheses. So in this case, we can expect that print heading, the function, has no parameters because there's no parameters being given. So this is where the book kind of does a display of functions. I'll briefly go over it, but then we're going to look at a couple of our own. So this is where we have this void display message, and it's just going to display a message. And then here's our int main. Now, I'm going to show you here in a moment why this message is up, why the function is up here rather than down here. And by the way, yes, this is still being done by a mouse. I know it looks like I'm using my pen, but it's a mouse. I'm going to give myself props. So, and now that I've done that, by the way, it's going to go to heck from here on out. So just FYI. All right, and the reason being is before main can call the display message, the compiler needs to know about this function. So that's why we actually have to put the function ahead of where we actually call it. Otherwise, if we put it down here, we would get an error because it does not know technically where that function is yet if it's down here. Now, there's a way to get around that. We're going to show you that in a moment. But for now, just understand that main is going to be called by the operating system. It's going to see out this message. It's then going to come up here, which is a void. So that way we know that it's not going to return anything. It's going to output what it's done, and then it's going to immediately come back to the next line of code and continue. So that's basically what I just said here is, again, message, and then it's going to return back to the next line. When you're calling functions, Main can be any number of functions. Functions can call other functions, but the compiler must know the following about a function before it's called: a name, the return type, the number of parameters, and the data type of each parameter. It doesn't need to know the body, it just needs to know this. This. So, how do we do that? How can we do that thing? Well, as we saw up here, uh, we just put the function before we called it. But there's another neat little way of doing that, and that's called function prototypes. With a function prototype, we can specify all these items ahead of time without giving it a body, so that way later, somewhere else in the code, we can put the function. As long as we put the prototype before wherever we're calling it, we're good. So what does that look like? Well, here's a good example. As you can see, the prototypes are here. Now, again, it needs to know the type, the name, the list of parameters, which in this case are none, and then you just put a semicolon, nothing else. If you don't put the semicolon, it's going to think it's the full function. That semicolon right after the parameter list tells it it's a prototype. And that's the important piece. This is just telling the compiler, hey, we're going to have a function with this data coming up soon, but it's not here yet. And what's nice about that is now in our main, we can call these functions and they're below the main, but because we did the prototypes, we now know, the compiler knows somewhere in this code to look for the actual function bodies. And when I say function bodies, remember, this is the functional body. So, prototype notes. Place prototypes near the top of your program. Program must include either prototype or full function definition before any call to the function. We've talked about this. Otherwise, the compiler just doesn't know, and it will give you an error saying that it can't find that function. When using prototypes, you can place the function definition in any order in the source file as long as there's a prototype. When using prototypes, yep. And you can, as long as you put the prototypes at the top, then your source, your bodies can be anywhere. And again, I know some organizations like their functions to be in alphabetical order. I'm not a big fan of that personally. But again, that is sometimes how things go. So we're going to go ahead and jump in real quick into something to give you an example. Here is our nifty little handy online compiler that I told you all about in previous module. Here's our old way of doing it. This is that spaghetti code. So we're typing this out, and then we're outputting it. Then we're doing it again. We're adding two numbers, and then we're outputting it. Frankly, these two lines of code, while they look different, they're the same thing, just with different pieces of data. And in this case, I would say this is repetitive. Why are we doing this more than once? Plus, if something needs to change with this, let's say we all of a sudden decide that we want to start multiplying everything instead, then I have to go find everywhere in the code that this is happening. Versus if it was in a function, I do it once and it changes it all. So again, this works. Let's go ahead and run it. And we now know that 5 and then 13. And now it's asking us for our first numbers. And I already see an error in my code. So this is going to be wrong. Yes. Let's go ahead and fix that real quick. And then we hit that again. We got 5 and 13, so let's do 4 and 4 again. Now it's 8. All is good in my world. Great. That's fun. And this works here. You know, if I was just writing this as a program, I would be done with that. That's probably what I would do. I would not take too much time to try to figure out how to make this nice and clean and reusable. It's, 15 lines of code? I'm not worried about it. But this is not normal. In fact, I have written very small console apps for my for many companies, and nothing is ever this small. So why don't we get a little smarter then? Instead of adding these numbers every single time, let's make a little function that adds the numbers. And in this case, we're actually going to allow whoever calls me to supply the two numbers. So here's my function, int add numbers, is the name. Here's my parameter list, and here's my body. And this works because I have the entire function before main, which is what calls this function. Now, what's nice about this is code reuse. I'm allowing someone to do addition on two numbers where I'm only having to write that code once. And now you can see, and we didn't change a lot. There's not a, if we look back and forth, we can see that I haven't done a whole lot to minimize the amount of coding, but I sure have made it neater and nicer. Oh, and by the way, because I use somewhat of a good function name, if I was another party coming by, another contributor in my team coming by, I can go int x1 equals add numbers 2 and 3. Now, if I was debugging this, maybe I would go look for that function, make sure everything's going correctly in that. But if I'm just looking at the code, this is almost self-documenting. Oh, okay, we're adding two numbers, 2 and 3. That's what's going to happen. I don't need to go find this function and verify that. I can go on the assumption that that's what that means. x2, oh, we're adding numbers again. And then even here, we're taking two variables because that's the name of the game, right? Our applications really want to be somewhat dynamic. We want to be able to give it data from a database or input from a user and get different results every time our application runs. And so this is a case where I'm taking in two numbers from the user. I'm passing those variables because they are of type int up into my function who's expecting data that's of type int, and then I'm returning that as an int. So let's see if that works. We're going to add 2 and 3, and we're going to then output it. Then we're going to call add numbers and add the next numbers. And now we're asking for the next set of numbers. And it works. Great. But again, I feel like I could make this even smaller. So how about this? Now this is a little bit fun. What I recognized from my code is every time I did this addition, I then always outputted the number as well. See, there's our C out there, here's our C out there, and C out there. Well, then I can probably put that into the function, right? So here's what I've done here is I've smoothed this completely out. I got rid of assigning the values and outputting it, and I did it all in one line of code. I said, take these numbers, add them together, and make your answer is this. Now, this is not going to run. Why isn't it going to run? Let's go ahead and hit run, and let's see our nice little nifty error. Compilation failed due to the following errors. In the main function, int main, error, add output numbers was not declared in this scope. And it's even telling me the line. Oh, that's right, because our function does not, where we're calling it, our int main doesn't know about this yet. So I gotta move this up to here. Now it should work. And sure enough, that's 5, that's 13. It's asking us for our numbers. And look, it's every time your answer is. And that's great. One of the nice functions about this is what if my boss comes along and says, oh, the user, or the client, changed your requirements. And now you got to say, yo, dude, your answer is, because we're trying to get, cheeky and fun. And, if you look around now, the internet's getting to be a lot more fun, less computer, right? I saw the other day Amazon was taking a little long to load its data and it had a dog, and I think it said woof woof looking for your data kind of thing. So pretty neat, okay, fine. Instead of having it to do it, like if we go back here, I would have to change that in all of these couts. Now I just change it in one line, run this neat little thing, and now all of a sudden it's changed everywhere. So there's some lift for us by using functions. Now, one last thing I'm going to show you here is let's put this function back down here. As we know, by doing that, we're going to get an error because it doesn't know about it. This is where we can do prototypes. And all we have to do is copy header here and put a semicolon behind it. It's not even hard. It really is. We don't want a body, so we have to put the semicolon. Now that I've done that, it knows that there is that particular function, and we can use it again. All right, next video, we're going to talk about sending data into a function. We kind of just did that a little bit, but now we're going to get a little bit more detailed in it. We'll see you in that video. Thanks.